Hi everyone, this is Infinity YouTube channel. Please remember to like, subscribe and share. So today we are going to continue from where we stopped in the Laplace transform. We are going to finish up the standard Laplace that we're doing, and today we are going to deal on the hyperbolic function of a Laplace. When I mean hyperbolic function, we are going to do the Laplace of Cosh at, Cosh at, and the Laplace of Cinch at. So these are the two Laplace we are going to deal with today. So I want to tell you, from hyperbolic function, it's known that Cosh at is equal to 1 over 2 into exponent of at plus exponent of minus at. So this is the value of a Cosh. Okay, so and it's also known from hyperbolic function. I'm going to solve two of them simultaneously. It's also known from hyperbolic function that Cinch at is equal to 1 over 2 into the exponent of at minus the exponent of minus at. So this is the difference between the Cosh and the Cinch. Just the Cosh is positive and the Cinch is negative. So now for the first one, let me call this equation 1, let me call this equation 2. Now for our equation 1, let's solve for the Cosh. Okay, let's solve for the Cosh. So we know that since Cosh at is equal to this, which means that the Laplace of Cosh at will now be equal to the Laplace of 1 over 2 into exponent of at plus exponent of minus at. So this is what we have. Next, one of the rules of Laplace is that the constants can come out of the Laplace just like an integral. So if the constant comes out, we have 1 over 2 into the Laplace of exponent of at plus the exponent of minus at. So this is what we have. So we know that Laplace of Laplace of exponent of at from our previous Laplace that we did is equal to 1 divided by s minus a. And with that same approach, the Laplace of minus at will be equal to 1 divided by s plus a. So that is what we are going to have. Okay, so on that note, we are going to add the two functions. So if you add the two functions, we have 1 over 2 into using difference of two squares. So this gives me s squared minus a squared. Okay, so by addition I have s plus a plus s minus a. So this is what I have. Okay, so the next is 1 over 2. Now s plus s gives me 2s, a minus a gives me 0. So I have 2s divided by s squared minus a squared. And of course these two can cancel out these two. So what I have is s divided by s squared minus a squared. So this is the value of Cosh at, of the Laplace of Cosh at. That's the value. Now on that same approach, let's do the Laplace of Cinch at. So the Laplace of Cinch at we know that the Laplace of sinh at will now be the sinh of at will now be equal to the Laplace of 1 over 2 of exponent of at minus the exponent of minus at. So this is what we have. So on that note, 1 over 2 comes out of the Laplace. We have the Laplace of exponent of at minus the exponent of minus at. So when we what we are going to do is to get the individual Laplace of this function. So if you should get the individual Laplace of this function, we are going to have 1 over 2 into the Laplace of this gives us Laplace of exponent of at gives us 1 over s minus a minus exponent of the Laplace of this exponent gives me 1 over s plus a. So just like the Laplace of Cosh, we just add this value. So we have 1 over 2 into the denominator. We have difference of two squares. We have x squared minus a squared, and adding we have s plus a minus s minus a. So that's what we have. So breaking it down, we have 1 over 2. Now s cancels. We have 2a divided by x squared minus a squared. So 2 can cancel 2. So what we have is a divided by s squared minus a squared. So this is the values of Cosh and Cinch. So I hope this video was useful and helpful. Please remember to like, subscribe, and share. Thank you.